All right. On the orange juicy problem, what did you determine was the tangiest?
I said that mixture B will be, both of them are equally tangy because the fractions are equal.
Okay, because the fractions are equal. So, if you had them in a clear container, do you think how would they look?
They would look the same.
They would look the same. Okay, what did you do for number 2? I'm looking at the math. What do you call that process?
Cross multiply.
You cross multiplied. How did you know to cross multiply?
Because whenever you want to see if something's equal, you have to cross multiply.
Okay. Okay, excellent. Let's look at Father Christmas. On the Father Christmas question, what did you come up with?
I got 180.
Excuse me. How did you come up to 180?
Because I added 168 because the copy should be 168 centimeters high. And I added 6 because I said you needed 6 milliliters of paint. And the answer was 174 and I rounded to 180.
Okay. But if you are using 6 milliliters of paint to paint the smallest Santa Claus, and you want to blow it up so that the other one is 3 times taller, then should you be adding? So what should your process be?
Multiply.
You should be multiplying. And so if it's going to be 3 times taller, do you think it's only going to be 3 times taller?
Yes.
Okay, so if we make this Santa Claus 3 times taller, is he going to look like that?
Yes.
He will? If you only do tallness, only looking at height, he wouldn't turn out to be a tall and skinny Santa Claus?
Yes.
He would. So what else would you have to multiply to get the... Huh?
We can multiply 56.
Nope, you have to do the height. And then also, if you draw a box around this Santa Claus and a box around this Santa Claus, how many times would this box be able to go on top of that box?
About 2 or 3.
Draw a box around each of those 2 figures. Now, how many times do you think this box would fit on top of this box?
6.
6 times? Okay. So, if it's fitting 6 times across, so that means 3 times here and 3 times over here, then what should you be multiplying by?
Times 6.
6 times what?
6 times 56.
Times 56? What's 3 times 3?
9.
Okay, so 6 times 9 would be
54.
54 milliliters. Let's look at the pendulum. Okay, explain your graph here.
I made it to match up with the graph. With the chart. And that's the number of swings, and that's the length of the string. So, some of the numbers with the swings and then the graph, so they're counted by 2.
Okay.
And by 5.
Okay. So, do you think that your data right here is proportional? The amount, whenever you increase the length of the string, did it also change your length of swings, number of swings? Yes or no?
Yes.
It didn't. When you changed the string, it did not change the number of swings.
Yes.
Yes. So if we had a very, very long string, would it be less or more?
It would be more.
So let's look at number 5. 5 centimeters was 58, and 25 centimeters was 25. So is that going up or down? It's going down. So would it be less or more?
Yes.
It would be less. Okay. Thank you very much, Hannah. Let's talk about the orange juicy problem first. Okay, what did you determine about the orange juicy problem?
That it was like.
Can you talk up?
What you mean?
All right. On the number one, question number one, which of those two would you think would be the most tangy?
Both of them.
You think both of them be the same? Why?
Because they both are equal.
Because they were equal. How did you determine that they were equal?
Because I cross multiplied.
You cross multiplied what?
1/2 and 3/6.
1/2 and 3/6. How did you come up with 1/2? Oh, okay. I see what you did. You did 1 orange to 2 oranges, and 3 waters to 6 waters. So you compared the ratios of the orange juice to the ratio of the water. Okay, so let's look at picture A according to picture B. So if you have 1 orange to 3 waters, or 1 orange to 4 as a whole, like 1/4, or and 2 oranges to 6 waters, or 2 out of 8. Compare those two ratios instead. So now, are they equal still?
Mm-hmm.
Okay. So you think it's proportional? Are the proportions equivalent?
Yes.
Okay. All right. And then, what things do you think will be different? Is there anything different about the two?
And one of them, you might like.
Between A and B.
Those readings.
Okay.
The only difference is that they just have different amounts.
Different amounts. So just the volume would be different. Okay. Let's look at Father Christmas. Okay. Tell me about Father Christmas.
Tell you my answer.
What's your answer?
54 milliliters.
How did you come up with 54 milliliters?
Because it's 54 because you need the amount of paint in the length and the width that makes 9, because the length and the width is both 3, and you multiply it to get 9, and you multiply 9 by 6. You need the 6 because 6 is the milliliters of paint, and you multiply 9 by 6 and it gives you 54.
54. Okay, that is excellent. That was absolutely perfect. Okay, and finally, on this question, just tell me, let me look at your chart first. Okay, here's your chart. Let me, if you had a shorter string, what would happen to your number of swings here? Would it increase or decrease?
Increase.
It would increase. How do you know? How do you know it would increase? What happened to your data as your length of your string decreased?
Got lower.
As your length of string decreased, what happened to the number of swings?
It increased.
It increased. So if I gave you a very long string, what would happen to the number of swings?
It would decrease.
It would decrease. So is the change proportional? Is it the change related to the length of the string? The change in the number of swings. Is it related to? It is related. So is the amount of change proportional? Like, does it change the same amount based on the number of swings?
Yes.
Okay. All right.